Right, so we've got 4 methods here in order to prepare aldehydes or ketones. The first one is ozonolysis. It is a process to locate the position of double bonds. In this reaction, what we'll do is we have a polysubstituted benzene, polysubstituted alkene, which will react with ozone, and it will form ozonide, which will further form these aldehyde molecules, and as a byproduct H2O2 will form. This H2O2 will be broken down into H2O and ZNO by zinc, as this is a mild oxidizing agent, and it may convert aldehyde into carboxylic acids. Now, if I say aldehyde, what I mean is that if it wasn't polysubstituted, an aldehyde would form conventionally. So, the mechanism for this reaction is quite simple. We are not going to be looking into the depth of it. We are just looking at it from the exam point of view. So, O3 will be added now, and ozonide will be formed, which is kind of like a house with oxygen at its corners, and the R groups are going to be at over this same place. So this is called an ozonide. Now, in the next step, this ozonide is going to react with Zn and H2O. This water is added to break ozonide. So what we'll do is we'll break this ozonide like this, and we'll break this ozonide like this. Now what we'll have is 2 aldehyde groups. Important to note is that the temperature of this reaction is 100 degrees Celsius, and then the byproduct is hydrogen peroxide, H2O2. So we've done this ozonolysis. Now we will move on to friedel craft acylation. Now what is acyl group exactly? Acyl group is this group, which is combined to a halide ion, so it is called as acyl halide. For this reaction we will be using CH3, C double bond O, Cl, and the catalyst that we are going to use is the friedel craft catalyst FeCl3, or we can also use AlCl3. So in this reaction we will use AlCl3. What we'll have is a benzene ring, and it has what we'll do is we will combine. We will first generate a nucleophile. So the mechanism is to generate an electrophile. An electrophile is generated by combining this acyl halide with AlCl3, which is a Lewis acid catalyst. We'll combine with that, and AlCl4 minus will be formed, and this will be the generation of electrophile. Now the second step will be attack of electrophile. What will happen is the CH3 C double bond O positive will make this go over here, and then this bond to be shifted over here, and then what will happen is we have this benzene ring now. This will attach itself to over here. The aromaticity is not intact, so what we'll do is we'll remove the hydrogen by placing the catalyst back into the reaction, and it will form AlCl3 and HCl, and then we will have the acetophenol molecule. One thing to also mention is that these catalysts should be anhydrous in nature. Now moving on, we have oxidation of 1 degree and 2 degree alcohols, which will give us 1 degree will give us aldehyde and 2 degree will give us ketone. So oxidation of alcohols. For example, we have butanol over here. It is a 1 degree alcohol. The reagents which are required are H2SO4 and K2Cr2O7, or we could use KMnO4, alkaline KMnO4 also for this reaction. So what we'll do is this will form, which is butanol. And then for what if we say we have a benzyl alcohol, which will also oxidize in the same reactants, and it will give us benzaldehyde. Now for acetone, for 2 degree alcohol, we have as an example isopropyl alcohol. We could write it like this, and we combine it, and then we form what we have is acetone or propanone, because this is isopropyl alcohol. One thing to note is that this butanol and will further oxidize into carboxylic acid as well. That is on another note. So oxidation is done. Now we will move on over to hydration of alkynes. Now, famous reagent for this is mercuric sulfate in the presence of sulfuric acid. The phenomena of tautomerism occurs in which enol form turns into keto form. So ketoenol tautomerism isomerism also occurs here. So what we have is, and then also Markovnikov's rule is also applied. So what we have over here, first we just use a methyne molecule, add water to it. Now the Markovnikov's principle doesn't apply over here, but tautomerism does. So it will convert into vinyl alcohol. We don't want vinyl alcohol, we want either aldehyde or ketone. So this will attack here, this will attack here, it doesn't matter which side. So CH2 combines to form CH, and then oxygen, OH and H. Now what we'll do is we'll throw this hydrogen back over here, and then we'll put this over here. So what we'll do is CH3, C double bond O, H. This is the shifting which will result us from a vinyl alcohol, which is ethanol, which is converted into acetaldehyde or ethanol. Now if we have a propyl group over here, and then we add water to it, what will happen is the H is going to follow Markovnikov's rule. It will attach to that carbon which already has H, or which has a greater number of H, and this will attach to over here. In the same reagents, mercuric sulfate and sulfuric acid, this will result in the formation of isopropyl alcohol, which will again follow, make another tautomer, in which this will shift over here, and then this hydrogen will shift over here. So what we'll have is CH3, C double bond O, and CH3, which is acetone or propanone. Slight correction to make is that this is not isopropyl alcohol. This is propene to all. Now, if we have methyl aryl ketones, we can also form acetophenone with it, or corresponding ketones as well. So what we are looking at here is ethinyl benzene, which looks like this. and then it will form what we have as, this will combine over here, this will go over here, and then what we have is C2OCH3. After all the rearrangement and everything, acetophenone will form, which is a methyl aryl ketone.